All right. Welcome, everyone. Thank you for coming. I'm Fred. I work at Blinkist as an Android developer, and I'm here today to talk about Dagger. Can everyone hear me back there? OK, that's good. So just a quick survey before we start. Who's using Dagger here today? OK, most of you. And who's never used Dagger before? All right. So a couple people. I'll be assuming some familiarity with Dagger. So if you've never worked with it, hopefully you'll learn a lot today. But there's a chance that some of the things, like it might get a little tricky to follow sometimes, but hopefully not too much. And I'm also going to be assuming that we have an understanding of what dependency injection is and why we'd want to take advantage of it. The goal here is to really go through a journey where we're going to compare and challenge many different aspects and many different ways of working with Dagger, basically. And we're always going to try to make things simpler and more convenient for us, basically. And even though this is not the kind of talk like how to use Dagger, we're still going to go through some of the basics and some best practice, basically. So why Dagger? Some people usually say that it's pretty complicated and hard to learn and use it, right? Well, the struggle is real. I've been there before. It's not an easy ramp up. It literally took me 5 minutes to find out this post on Reddit and put them together in the slide. But why is that? And let's go back in history a little bit. This is Dagger 1's API. So it's not extremely simple, but it's not that bad. It's just a couple of, it's not bad at all, actually. Just a couple of interfaces, a couple of annotations, and one abstract class. And you wouldn't really need to be familiar with all of those in order to use Dagger 1. Then if we look at Dagger 2 initial API, that was it. So it did start super simple. When you compare with Dagger 1, that's pretty impressive. And at that point, they were really trying to only keep the most safest and effective features they had, and they clearly achieved that. Then the API evolved a lot and increased in size. And today, there are many different ways of pretty much doing the same thing with Dagger, and that's probably one of the main contributors to its infamous complexity. But there is a positive aspect here, though, which is it's clear that the Dagger team has been working really hard to make things better. And the increase in the API and the complexity is just kind of like an undesired side effect of this. Not everything is there. I don't have producers there or Dagger Android, for instance, which we'll talk about later. So it's actually bigger than that. So maybe it's time for Dagger 3 so we can slim it out again, but probably not, even though it would be pretty cool. So it did start simple, and then it got complicated, but there are many positive aspects. There are many reasons for us to still want to use Dagger today, and it's important to be familiar with them. Compile time safety is definitely my favorite one. It scales really well on most setups. It's the best performance out there. And no boilerplate? That might sound a little unusual too, yes. But the truth is, even though Dagger can be pretty verbose sometimes, there isn't really a lot of boilerplate around, and we're going to see that through the presentation. Some of these might not be extremely relevant to your project, though. Dagger might not be a great fit for you. I'm not here trying to sell Dagger. It's a heavy solution, and it's built to scale. And I'm going to try to illustrate that with this chart. This is just here really to illustrate an idea. I don't have any data to back it up. But as we can see, Dagger's verbosity starts very high from the very beginning. And it grows, but not too much as your project grows. So it's like your DI setup verbosity versus your project size and complexity. On the other hand, other simpler solutions like handmade DI, for instance, they usually start very simple, but then they grow as the project grows. So it's clear that Dagger isn't for every scenario, but it does pay off at some point, which is where the lines cross, basically. But I also don't believe that Dagger only pays off on extremely big projects. I think there's a way that we can use it and keep things simple, in a way that we can still fit it in good scenarios, in simpler scenarios, like side project you might have or something like this. So the goal of this talk is to try to bring this line down. So try to find ways to use Dagger without overcomplicating things, basically. If you have extremely complicated and complex requirements and you want to solve them and map them through DI, that's probably not going to work for you very well, but I think in general we can do better. So another concern people have with Dagger is build times. And Dagger depends on annotation processing, and it will affect your build times. So there are some things we can do about it. We can, for instance, disable code formatting, because that actually takes quite a bit of time. I took this from the Dagger docs, so it's just a compiler option. The nice thing about this one is that it's going to be disabled by default with the next Dagger version. And we can also enable greater incremental compilation. So these two are just a couple of compiler options you can add to your Gradle setup that will help you a little bit. But then The latest version of Kotlin included lots of improvements to the Kotlin annotation processing, including incremental annotation processing, so that's pretty cool. And again, in the way to take advantage of that is just to update Kotlin to the latest version and add a couple of Gradle flags. So it's again an easy win. And then there's this, which is not complete, I believe, but it works. It's basically a Dagger implementation based on reflection. And the idea here is that you can use that while you're developing, just so you don't have to go through the annotation processing phase while you're building, basically. But if build times are really your main concern and main problem, Dagger is probably not going to be your bottleneck. And the only real solution for a problem is modularization. This is a dense topic. It deserves its own talk. We're not going to talk about it here. But I will link to Lorenzo's talk from DirectCon Italy a couple weeks back. He talks exactly about Dagger and how to use it with multi-modules. And also Ben's blog post, actually, about how they did multi-module and Dagger setup on the Plate app. That's pretty interesting. And he's actually right now talking about best practice for a modularized app in the other room. So you can actually also check the video later once it's uploaded. Or you can switch rooms, but please don't. After this colorful introduction, let's switch to dark mode and get started for real. So let's start with two simple business classes. Let's start with a business util and then a business runner that use the business util in its business. So the idea is that I want Dagger to be able to create those dependencies for me, right? So if I want to have that here, all I have to do is to annotate the constructor of these classes with inject. And that's it. Now these two objects form my object graph, and Dagger understands how to create them, and understands that in order to create a runner, it needs to create a util first, and it doesn't matter how complex the dependencies are related to each other and how many dependencies you have, Dagger can handle them as long as it's a valid dependency graph. So at this point, let's take a step back and appreciate this a little, because there's no boilerplate or verbosity here at all. It's just one annotation and it's done. Obviously, we cannot do that every time. Like we cannot do that for classes that we don't own, but we can do that everywhere else, and we should. So this leads me to tip number 1. During your journey, we're going to have short breaks, and we're going to present some tips, and that's the first one right in the beginning. So constructor injection is great. With Dagger, we don't really have to write constructor boilerplate, basically, and we should embrace that and do constructor injection whenever we can. So let's say at some point I decide that I don't want to have I want my business runner to be just a single instance across my application. So I can just annotate it with singleton, and that's it. Now whenever I ask Dagger for an instance, I'm going to get the same one every time. For my business util, right now, whenever I ask for one, I'm going to get a new one. But let's say my business util is a stateless class, so it's like a thread safe. And even though it wouldn't really be necessary to share an instance of the business util across other objects, it would be fine if that happened. If that's the case, we can actually annotate it with this last known annotation called reusable, which basically tells Dagger that, hey, you do whatever you want. If it's easier to create a new instance, you do it. If you already have a previously created an instance to give, you can give it to me. But what's the point of this? The thing here is tip number 2. Singletons are expensive. There's a double-checked lock-in underneath to make sure that the instance will only be created once. So even though it's very simple to add scopes with Dagger, we should think twice and only do it when it actually makes sense. So if you're annotating things with singleton just to try to minimize allocations, it's probably a good idea to go with a reusable instead. That's the point. So again, we have our object graph, we're controlling scope, we're doing everything, and so far it's just some annotations. So again, let's take a quick step back and appreciate this a little bit, just one more time. So how do I access this instance, right? That's where the component comes in. We need an entry point, and this entry point is the component. So it's basically just an interface annotated with component. Right here, we actually also have to annotate it with singleton, just because of the way Dagger associates scoped instances with instances of components. So we basically have to declare here what's the scope that this component represents. So this is an application component, so it makes sense that it represents the singleton scope. But if you have another component that represents a smaller scope, you can basically create another annotation for you to have a more meaningful name. We're going to talk a little bit more about scopes later on. So let's just keep moving. And what we can do here is basically expose any object from our graph here in the component. It doesn't necessarily need to be a vol, it can be a function, but a vol looks better. And then if I want to get a business runner, all I have to do is talk to this entry point. So Dagger automatically generates the implementation of it, which has the same name, but with the Dagger prefix. And then you can just, in this case, call create, and now you have an instance of your component. With that instance, you can basically access any method you have there, or any vol, in this case, business runner, and do whatever you want with it. So it's pretty simple. But maybe that's not how you're used to work with Dagger components. Maybe you're more used to do member injection. In that case, things are a little bit different. Instead of exposing your dependencies directly in the component, you create a method that receives the object where you want to inject your dependencies, basically. So let's say I want to inject my business runner in my activity. I'm going to have a method that we usually call inject that receives the activity there. Then in my activity, I can have a member annotated with inject, and basically do the same thing I did before. Just talk to this entry point. Get the component, create it, and call the method, passing this in this case. And with this, Dagger is able to initialize my injected member. So if you've been working with Dagger, that's probably a pretty usual thing you do. But let's take a closer look at this. There are many things there that we usually take for granted. Let's take a closer look at that line specifically. That is a member in an activity. So why is it public? The only reason is Dagger. Dagger needs it to be public so it can set, public or protected, so it can set a value to it without using reflection, right? And it's a late init var just because it's only going to be initialized after you call inject, so you can't initialize right away. So we're kind of also giving up on compile time safety a little bit, because if you forget to call inject, things are going to break, and this thing we're never going to be initialized. And it's a var instead of a vol. So we're kind of giving up on immutability here just because of Dagger again. So when you take a step back and look at this from this perspective, it's not great. It's actually pretty ugly and complicated. Or what we had previously was just so much easier. You can just have a proper private vol initialized right there with your dependency, and that's it. So one interesting thing to keep in mind when comparing these two ways to interact with the Dagger component is how they scale. So if I want to inject the same business runner in 5 different activities, I don't really have to change anything there, but I need 5 different injects, 1 per activity. But then the opposite is also true, right? If I want to inject 5 different business runner in the same activity, I need to expose all of them, my component, and I just need 1 inject, and that's it. But let's try to think of a real-world situation. I've seen that a lot, like a list of dependencies and activities, but it's not really something I try to have. It's something I usually try to avoid. I try to limit the responsibilities and dependencies of activities, right? So that's not something I would like to have. I would rather have something like this instead. And in this case, it makes sense moving away from member injection and just going with whatever we had before. That component call looks fancier than before. It's just an extension, and we'll get to it soon enough. So tip number 3 is avoid member injection. Things get simpler if you just expose your dependencies directly in the component. So let's see what we have. We have our 2 business classes. They're currently our object graph. One is a singleton, the other is reusable. And then we have our component. And whenever I want a business runner, I can just ask one from the component. But I don't really want to create an application component every time I want to get a dependency, right? That doesn't make sense. So what we usually do, we hold the component as part of our application class. And one nice trick that people usually like to do is to have the component as a static member there that we can just initialize in the onCreate, for instance. So the nice thing about this is that once I'm in an activity and I want to get a dependency, I can get it right there, right away. I don't need any by lazy or anything because it's a static member. So it's fine if at that point I don't have my application instance, which I don't, because I only have it after the activity is attached. So I don't have to wait until onCreate or anything to get my dependencies. I can get them right away. So that's cool. But at the same time, now anyone, like any component from my app, can easily access my component because it's a public static member in my application class. So things get a little less encapsulated. And I don't know, it feels a little awkward to have this static member there hanging around. But you gain this, though, and this is pretty cool. What's the alternative? We could have the component as a regular member of the application class, so things are a little more encapsulated. And one thing I like to do is to hide this behind an interface that I implement there in the component, just a simple interface that exposes the component. The nice thing about this is that if, for instance, I want to override that and provide a test component in my test, for instance, this makes it a little easier, so I kind of like this. And then we can create a little cute extension that I'm calling there injector, but you can call it component like we had in the slide before. It doesn't really matter. But the component's kind of like an injector in this case. And it's basically just to hide the cast and to make things look cuter in the activity. And then finally, in the activity, it's kind of what we had before, but now I need that by lazy. Because now, in order to access the injector, which is our Dagger component, I need an application instance. And I only have that after the activity is attached. So I need that by lazy. That's the downside side of going with that. And the thing is, moving forward, we'll see that I'm going to be more interested in injecting view models into activities. And view models can't really be injected before, can't really be requested before the activity is attached. That's like a limitation from the framework. So I'm actually fine with that by lazy because of this. And we're going to move forward with this setup. So at some point, we're going to need to bind external classes, right? And then finally, we're going to need modules, unfortunately. So modules are just classes or objects, and you'll see why, annotated with modules, that you can have methods annotated with provides that returns whatever you want to bind to your graph. So in this case, I'm returning just the shared preferences. And then in the method, you can have dependencies that are objects that also belong to your graph. So it's pretty simple, it's pretty straightforward. But when you look at this and you compare it with what we had before, just a constructor injection, you really feel the weight of constructor boilerplate. So this just like makes us make sure that whenever we can use constructor injection, we should. So we can avoid things like this. We can avoid modules and whatever. But for external class, we can't escape. We have to have something like this. So there's nothing really here we can do to make this significantly better. But there is one thing we should keep in mind, though. Oh, of course. And then after you have the module, you have to install it in your component by referencing it in the modules parameter of the component notation. Nothing special there, just more boilerplate, just more reason to try to avoid this as much as you can. The thing to keep in mind here is that if all your methods, provide methods from a module are static, then Dagger doesn't really need to instantiate the module, and that's a great thing, especially if your project is big and you have lots of modules. But even if you don't, it's such an easy thing to do that it's something that we should always try to do, like have all your or provide methods as static. And in Java, that's pretty straightforward, but in Kotlin, it gets a little tricky because you can't simply have static methods and classes. There is a way to do it with companion object. It looks pretty ugly. The proper way to do it here is to have your object, have your module be in an object, and then you can annotate your methods with JVM static. And it might seem that you're going to have your module instance because there's an object there, and that's an instance. But because it's going to be an unused instance, R8 is going to be able to get rid of it, and you're going to be fine. It's going to be a proper class with only static methods. That's a big win. And then we saw that module depended on the context, right, to create the shared preference instance. So at some point, we're going to need to bind the context. And the context, again, we don't own it, so we can't just add inject into the constructor. And it's not something that we control creation, so we can't have inside a provide method inside a module. So the context is this classic example of this case, or like, how do I bind an instance that I don't control creation? And how we used to do that in the past, which we shouldn't do anymore, is to have something like an application module that is a very simple module that receives a context as a constructor argument and then exposes it in a provides method. So it's super simple. It receives something and then exposes it, and that's how you bind your application context. You can actually make this look a little cuter thanks to Kotlin, and that's how you would build a component. Now, we can't just simply call create. We have to use the builder, and the builder will automatically include a method to receive your module that you just installed, and then you can pass a new instance of your module with your application context. This is just not great. First, we cannot have only static methods anymore for that module, and just the fact that we need a module just to bind an instance is a little annoying. So we can do better. Starting with Dagger 2.9, which was released like a couple of years ago, we can use the builder directly, right? So the builder is just an interface that you can annotate with component.builder, and it must have a method that returns your application component, and then you can add other methods to bind whatever you want. So if you want annotated with bind instance, so if you want to bind the application context, you add a method annotated with bind instance that receives your context, and that's how it's going to be bound to your graph, basically. So the way you create this, it's pretty much the same to what we had before, but instead of passing a module, you just pass the application context. So that module we had before dies. We don't need it anymore. So that's the win here. We don't need a module, and it's better. But it can get better. Since the last version of Dagger, 2.22, which was released like a couple weeks back, we have the factory, which is kind of like a builder, but better. So it's also an init interface. This time you annotate it with component.factory. And this one only has one single method. So it's just something that returns your application component, and then you can annotate individual parameters with binds instance. So in that case, we just have a context, and you annotate it with binds instance. The nice thing here is that with the builder, if you had several different binds instance methods, it would be possible to forget to call one of them when you're creating your component. And here, since it's a single method, you must pass all the parameters in order to successfully call the method. So this brings a little more safety. And it's a little less verbose. So it's a nice thing. And it looks cute when you want to create your components. Just factory.create, and that's it. And then you pass whatever you want to bind in a single method, and that's good. So tip number 5 is use it. Use the component.factory. Forget about modules with constructor injection. Forget about the builder. The factory can do everything, and it's less verbose, more safe, and better in general. Okay, so we have our 2 business classes with constructor injection. We just bound our context with a factory. We bound our shared preference with the module. We went through most of Dagger's API, I mean the main parts at least. Not most of it, definitely not. And we've been low-key talking about injecting things into activities, and that's when subcomponents show up. So let's talk about it. There are 2 main reasons to the subcomponent. First one is encapsulation. So let's say you have a feature that have this specific dependencies that are not really used in other parts of your app. You can create a subcomponent for that, and then other parts of your app cannot access those dependencies specifically. So things get more encapsulated. It's interesting, it's cool. But then, when you want to bind classes to subcomponents, you're going to need modules. So if you start encapsulating things around, you're going to start writing modules for classes that you want, that you could use constructor injection instead. So this has a price. And because it's not essential, even though there's a positive aspect there, since it's going to make things more complicated, we're not looking to it, because we're trying to keep things simple, right? The other reason is scoping. So we talked a little bit about scoping already. The idea is that with subcomponents, you can have inner scopes, like smaller scopes within your application scope. For instance, an activity scope or a fragment scope, which are like the classical examples of this. So that's pretty cool, because let's say I want to share an instance of an object between fragments within the same activity, but I don't want that instance to live through my entire application. So I can just have that object activity scoped, so it's only part of that activity, and the fragments look at the same object. You can inject the object in different fragments, and they're going to receive the same object. So that's cool. So this is a pretty usual setup we can have with Dagger. We have our application component, and we have subcomponent per activity. The thing is, this also has a price. Things start getting a lot verbose here. All of a sudden, if I want to create a new activity, I have to create a subcomponent, create a module, maybe a couple modules, wire them up with the application component, write the code to create the subcomponent, inside the activity. So that's probably the point where Dagger starts feeling like that's too much, you know. And one thing that helps us here in this kind of setup is Dagger Android. So let's take some time and talk about it. First thing is that, yes, it's great for that setup. You're gonna be able to achieve that with less code, basically, because it generates a bunch of stuff to you. But it's still verbose. It's still less flexible than not using it, and it still increases the complexity of your setup. So it's not free, basically. One nice thing about it, though, is that it's real DI. And with that, I mean that, like so far we've been always talking with the injector in the activity. It's like injector.inject or the name of the dependency or component, whatever. And that's not really real DI, right? Because now you're aware of where your dependencies are coming from. Real DI is when you have constructor injection, for instance, because you just have your dependencies from your constructor and that's it. With Dagger Android, we can achieve real DI for activities because it has this cool Android injection .inject that you can basically hide in a base class, and then in your activities you can just do you just basically annotate your members that are your dependencies, and they get injected, and that's it. It's super transparent. But then you get stuck with member injection, so it's again not free. But the most important thing about Dagger Android is probably this other thing, like it decouples injection sites from injector. So when you start working with with several different modules, then it starts making more sense. However, it works well with library modules, but it doesn't really work with dynamic features. So it's not like, oh, it's multi-module, I'm going to go with Dagger Android. Not really. If you want that dynamic features, that's a deal breaker. So Dagger Android has this powerful name. Like, we look at it and you're like, yeah, I want to use Dagger on Android, so I should use Dagger Android. But not really. It's a very specific product, and we really need to take into account all those things. So if you really want to work with library modules and you don't care about dynamic features, it's probably a good call. If you really want to stick to that subcomponents setup, it's also probably a good call. But if you want to keep things simple, like we do here, maybe it's not. So what we have to ask ourselves here is, do we really want one subcomponent per activity? Is that really necessary? Well, I kind of like the idea of being able to have activity scopes and fragment scope. That's pretty cool. And we can actually have that without Dagger. We can use ViewModels for that. We can basically use whatever Android gives us for free. And today, probably the easiest way to share whatever you want among fragments within the same activity is with ViewModels. It's like trivial. So instead of complicating our Dagger setup to create those scopes for us, we can just take advantage of ViewModels. And I'm not advocating against subcomponents and Dagger Android here. They're powerful, and you can build powerful things with them. But if all you're doing with them is like the simple stuff, like a simple activity and fragment scope, and maybe just sharing your objects around these scopes, and maybe binding things that come from the activity or the activity itself to the graph, if you're just doing those simple things, you can live without it. You can do things in a simpler way. So because here, that's our goal, let's explore a world without subcomponents, and let's take a deep dive on ViewModels. So we're going to start very simple. Instead of injecting our business class directly into our activity, we're going to inject our ViewModel that has our class. So let's start very simple. One thing we would do here would be to create a ViewModel factory, and that ViewModel factory would receive the same dependencies that I have in the ViewModel, which in this case is just one. And then in order to implement an interface, I just basically create a new instance of my ViewModel with the dependencies I got in my constructor. Then I can just bind this ViewModel factory and expose in a component, and finally do the usual thing we would do when asking for a ViewModel, like for Android, basically. And whenever we need to pass the factory, we just get it from Dagger. So there are lots of problems here, two mainly. First, I don't really want to write all that code every time I want a ViewModel. That's too much. And the second, I don't want a dedicated specific ViewModel factory for each ViewModel I create. That doesn't scale well. So let's fix that first. Now we're also going to bind our ViewModel, so it's going to be part of our graph. And we're going to change our implementation of the factory. We're going to look at it. The thing we want is to be generic, right, for any ViewModel. So let's do that. It's going to be a generic class of T, which extends ViewModel. And as a dependency, it will receive a provider of any ViewModel. It's a Dagger provider. So that's an important point there, because we don't want to have to create a ViewModel every time you create a ViewModel factory. So we just ask for a provider, and then whenever we actually need an instance, which is when the create method is called, then we ask the provider for an instance. Now, whenever I want to expose this factory, I can basically use the same class and just specify explicitly the type of my ViewModel. But I can stick to the same ViewModel factory now. I don't have to create a new one for every ViewModel I come up with. And things in the activity don't really change. It's the same. So let's fix that now, because that's not great. Nothing's going to change in the ViewModel. But now, instead of exposing the ViewModel factory, we're going to expose the ViewModel itself. This looks a little weird, like at first, because we don't really want an instance of a ViewModel directly from Dagger, because we don't want Dagger controlling its scope. We want Android to do that, because that's the whole point, right? But the trick here is how we're going to implement our factory. So it's a little dense, but let's try to go step by step. This is actually an extension function on top of a fragment activity. It's fragment activity just because that's what ViewModel providers expect in the auth method. So I'm basically complying with the API. And there I receive a reified T type, which is a ViewModel. And then as a parameter, I receive a provider, kind of like the provider we had before, but not a Dagger provider anymore. It's just a lambda that returns a ViewModel. Then what I'm doing there inside a function is basically what I was doing in the activity. I'm calling ViewModel providers.auth, passing this, which in this case is the activity, because that's an extension on top of the activity. And for the factory, I'm actually passing an anonymous implementation there that I'm writing on the spot. And the implementation is pretty much the same as what we had before, too. It's just delegating the creation to the lambda we received. And then we're calling get. So even though this looks pretty convoluted and a little weird, it's actually doing something simple. It's just wrapping the lambda into a factory. So we pass a lambda because we know how to create a view model. It's just asking for Dagger since it's now bound to the graph. But we don't want to have the power to create them. We want to delegate that to the factory. So in the activity, that's how it looks. I can basically call directly the extension, and the lambda I pass is basically just injector.myViewModel, because now it's part of the graph. I can just access it right like this. And even though that line, that lambda, is not going to be executed every time we go there, right? Because we're passing to our extension, and it's wrapping in the factory. So that thing is only actually being executed when the factory wants. So if you rotate the activity, for instance, even if you pass there, that lambda is not going to be, it's not going to run, because the factory will understand that the view model has already been created. It's going to reuse whatever it has created before. We can still do better. We can combine the bylazy with this extension we just created. And for that, we're going to ask some help from KTX. So we're going to add activity KTX and fragment KTX as dependencies. And we're going to change just a little bit our extension. Now, instead of calling get view model, I'm just going to call view model. And that was the only other change there. Instead of calling viewModelProviders.off, I'm calling this nice new extension called ViewModels from KTX, which basically does the same, but instead of returning a view model, it returns a lazy reference of a view model. So it's exactly what we want. So now, instead of doing the by lazy and then calling our extension, we can just do that. We can just do my view model, which is going to be by view model, and then I pass the view model from Dagger as a lambda. The view models extension is just like the view model providers. It also receives a factory, and we didn't change anything there. It's the same factory wrapping the lambda. So in the end, that's what I get. That's finally something decent. So let's say I want to add another view model in my app, for instance. What I do, I just annotate it with inject, as I would do for any other class I'd be interested in binding. I expose it into in the component, because I want to access in the activity, and then I just use the extension we just came up with, passing the lambda with the injector call. So things get simpler, get simple after you have all that in place. We can easily replicate the extensions to fragments. So we can have a version where you can ask for a fragment scoped view model, and the other version where you can ask for an activity scoped view model. And that's how you get the scopes for free. So KTX is super cool, and they also have 2 extensions, so we're basically calling a different extension for each version of the method. And then when I'm in a fragment, whenever I want a fragment view model, I just do by view model, and when I want the activity view model, because maybe I want to share some object with another fragment or with the activity itself, I just ask for an activity view model. And that's how we get our scopes, basically. So I know there was a lot of code to get here. It was 3 weird extensions that we wrote. But it's just code that we write once, and that's it. You can hide behind a library or a library model or whatever, and it scales well, basically. So tip number 6 is control scopes with view models, or at least consider doing it. Just take advantage of whatever Android already gives us, and that's one of the things. There is another thing, though, that we usually do with subcomponents that I want to cover here, which, for instance, let's say all of a sudden my view model now receives this message, which is something that comes from the activity intent. How do I make it part of the graph? With subcomponents, it's pretty simple. I can just take advantage of the factory or the builder or the module with constructor argument, whatever, and I can pass this before injecting things into the activity. So while I create my subcomponent, I can pass whatever I want to bind, like something from the intent, and it's going to work. But if you really use subcomponents just for that, it's overkill. We can do that with our subcomponents. First alternative we have is we can just move our message outside of the constructor and set its value after we have the view model injected into activity. Looks good, right? It's simple. So since we want to keep things simple, but not this time. We don't want to give up on Dagger's compile time safety. We want to make sure dependencies are ready to go as soon as they're injected. If I have to call something or set something before I can use my dependencies, I'm going to forget, and things are going to break. So we really, really don't want to do that. So let's move our message back to the constructor, and what's the alternative then? We can use Assistedinject, which is a third-party library that solves this specific problem. So what we can do here is, instead of annotating with inject, we annotated with Assistedinject, that's from the library. And then any parameter that we want to inject in an assisted way, like the message, which is not part of the graph already, we annotated with assisted. So it makes sense, right? And then we're basically going to use the factory pattern. So it's basically the same as we do in the component. So that's the nice thing about it. It kind of matches what we already have for the component. So it's like consistency. It's good. It's basically the same thing. Like it's an inner interface that is annotated with something, in this case, Assistedinject.factory. And it has a single method that receives all your assisted parameters, in this case, just message, and then returns your view model. And then whenever I want to use it, I can just expose, instead of exposing my view model directly, I expose that factory, like this. And instead of doing something like this, like we've been doing before, we would ask the injector for the factory, then call create, and then pass whatever. The point is that the implementation of the factory is generated by the library. So you can just use it like this. It's a library, so you have to add dependencies. And unfortunately, that's not the last step we have to go through. There's still one more thing we have to do, which is this. We need a module annotated with assisted module, and then this is going to generate another module that we have to reference in the module where we added the annotation. So it's really weird. And it's really sad that we have to reference generated code directly. But it's something in theory temporary. There is an issue open in Dagger to try to convince them to support automatic module discovery so third-party libraries can do it. So in a future, hopefully, we won't need to do that. But again, this is something you write once and you forget, so it scales well. It's not something you have to do for every factory or anything. You do it once and that's it. It's just the entry point the library needs in order to talk to Dagger, basically. And you don't necessarily need a dedicated module to it. You can just annotate whatever module you already have installed in your component, and it will work. So it's a little unfortunate, but it's also not that bad. So tip number 7, and final tip, is take advantage of Assistedinject. At least know that it exists, and it can help you in those cases. I like it because it's a very focused library, and it solves the problem really well. So to wrap up, let's go through the tips, just to remember them. First one is constructor injection. I can't emphasize that enough. That's one of the best parts of Dagger, the fact that you can bind things that you own with no code at all. It's just one annotation. So make sure you take advantage of that whenever you can. Singleton's expensive, so think twice before using them, and know that reusable exists. Avoid memory injection. Things usually get simpler when you expose your dependencies directly through your component. Always go for static provides method. There's no reason to go with something else. In the past, we used to say that it was cool to have non-static provide methods so we would be able to override them. That's not a good reason anymore. It's static all the time. Use the new component .factory. It's the new thing. It's better than module with constructor arguments. It's better than builder. And consider controlling scope with ViewModels. At least know that that's an option. And finally, take advantage of Assistedinject. So these two right there, take those with a grain of salt. They're very opinionated, and it really depends on exactly what you're trying to achieve, what's your setup, what's your team, what's your project. The rest is almost universal truth, though. So I have some of my resources here, references, and these two deserve their own slide because they're definitely the main source of inspiration for this talk. So that missing guide, How to Use Dagger 2 by Gabor Varadi, and Keeping the Dagger Sharp by PI. Those two were definitely, like, when I read them, it was the point where Dagger finally clicked for me, and I realized I could do things better in general than my current setup I had. But I also listed all I listed the main references that helped me build this talk. And especially those last two, that's where I took most of the ideas that I showed you in order to integrate the view model and the Dagger, basically. While building this talk, I also ended up writing some blog posts. So some of the things we talked about, you might find some more details in those blog posts. So maybe you can take a look at them later. And finally, you can find all the code in this repo. The master branch has a nice commit history with all the steps we went through, so you can actually like explore everything we did step by step and just look for whatever you think is relevant for you. There you can also find a link to the slides. So if you're interested in taking a look at it later, you can just open the repo and there's a link there. That's it. I'll also be publishing the slides on Twitter, and I'll be around if you have any questions later. You can find me around here. Thank you very much.